All right, so we just dealt with graphs, dealt with tables of composite functions and operations of functions and how to evaluate each one of those. So we've dealt with all of that. That's pretty much the major portions of it. So the last major portion that we need to deal with is come out decomposing composite functions. So in other words, we know there's a bunch, like when we do composite functions, we have a function inside of a function. So what we're going to have to do is figure out, okay, what are those two functions that make up that composite function? That's what we're going to deal with this today. All right, so with that, let's go and go to the next slide. All right, so with that, when it comes to our composite functions, just like I've said already, the f of x function or whatever is the outside function would be the outside. So in this case, f of x is the outside, g of x is on the inside. Kind of like when we talked about the when we evaluated things and we evaluated the composite functions, we talked about there was an inside, there was an outside. We dealt with the inside first, then we did with the outside part. Kind of the same idea, same thing we're going to be doing with. So here, g of x is on the inside, f of x on the outside. That's going to be important for what we have to figure out and do when it comes to determining what the g of x function and f of x function is. All right. Now, with that, I'm going to also do the g of x portion, g of f of x. So we have f of g of x and g of f of x here. So here in this case, f of x is on the inside, g of x is on the outside. So each one of these are inside outside portions. And then when we talk about this, we're going to talk about what is inside, what is outside. One of the great things about understanding this is that it's going to help us when you go to calculus and you have to do the chain rule. So there's a thing called power chain rule, there's a thing called chain rule when it comes to derivatives. And when it comes to this portion with composite functions, if you can figure out what the inside and what the outside is, you can be able to do derivatives a little bit easier because you can determine that. So this whole lesson right here is very good if you're planning on going to calculus. Very, very good. All right, now the outside function will always be the simpler one. It would normally just have like that, maybe like the absolute value bars with x in the middle, or the just x squared or x cubed or 1 over x or something of that sort. It's always going to be something simple. It's not going to be as detailed, I should say, as the inside function. So the outside function is going to be very simple. It's going to be like 1 over x or x squared or square root of x or absolute value of x or x cubed or x squared or something of that sort. It's always going to be something like that. Cosine x, anything like that. 2 to the x power, anything. All right. Now, with that, the inside function is where it's going to be more complex. So the inside function is going to have like the 2x plus 3 or the 5x cubed plus 19 or something of that sort. Is going to be more complex inside of it. So when we deal with this, the outside function is going to be the simple one. The inside function is what you're putting into the function, that simple function there, to make it look more complex. So really, this next part that we're going to do is not going to be that hard. You just kind of have to figure out, okay, what is the outside function? What's the biggest part of it? And then, okay, what is the inside? So if you're one of those people that can see the big picture, you will be able to see, okay, this is the outside, this is the inside. If you're not one of those people, if the people that can see details, you can probably see the inside one easier than the outside part. So probably a good thing that both of them you can actually work together and be able to find it. So again, that big picture probably would see the outside one first, and then the people that see the details, that can see the inside portions, they will see the inside first. So it's up to you. It's up to you how you do it, but you're going to have to be able to do both. That's the key. And I think there was one other part down here. Yep, there's one other part. Now for our notes, we're going to use h of x for f of g of x. But also h of x could be g of f of x too. So we're going to just use h of x, and we're going to talk about f of g of x for our notes. So the outside function is going to be f, the inside function is going to be g. So with that, we're going to go to example 1, and we're going to talk, well, example 1 has a, b, and c in it, and pretty much that's the whole lesson. So let's go to example 1 now. Part A. And so here we're given h of x, and we're going to determine what f of x and g of x are, given that a is equal to h equals, sorry, A is f of x equals, sorry, A is h of x equals x plus 4 quantity squared. Get a little tongue tied there. All right, so again, we're going to talk about our different pieces of it. And just like we did, I'm going to come back really quick here. Just like we did here, we said our outside function was blue, inside function is red. We're going to use those exact same colors when it comes to our notes today. So outside function is going to be blue, inside is going to be red. All right, so with that, let me go and pull up my Elmo, and let's go and work on this. All right, so again, the outside function is going to be blue, the inside function is going to be red. So with it, if you can kind of see it already, what's on the outside portion is like this part right here. What's on the inside parentheses or something, is this portion right here. So I'm going to rewrite this so that it kind of looks like the outside inside portion of it with our different colors. And again, if you have colors at home, or if you want to go to Dollar Tree and actually get like some colors there, I got all my colored pens from Dollar Tree, so it's like $1 only. So like, go for it if you need to do colors and stuff. All right, so again, the red here is the inside, the blue is the outside. So just like I said before, the outside is really going to just have like x in it, but it's like x squared or x cubed or x to the whatever power, or square root or absolute value. So my f of x function here, we know the outside is squared, and we're just going to put an x right there. And again, this is our outside. Now for our inside, whatever we put into the problem, sorry, it should be g of x, not h of x. So the part that's inside of it is x plus 4. Okay. So just to reiterate it and go backwards, like to go from here back to this here and see if it gives us the same answer. We know we're talking about f of g of x. And this is how we're going to evaluate this, how we're going to look at it and be able to tell like what's really happening. So f of g of x. So we know first off, we write down the outside function. So here our outside function is x squared. All right. So now when we actually have to do it, we're going to be dealing with the outside function, and we're going to put the x plus 4, which is, we say, is g of x. All right, and so just like we did with our notes for composite functions, the composition of functions, we're going to substitute x plus 4 in for x. Wherever we see x, we put x plus 4 in that spot. And look at that. It is exactly what we started with. So again with this, please do not overthink this. Don't put too much thought into it, but wait, why can't it be this and why can't it be that? There's an outside part and an inside part. And if the outside part is an exponent or absolute value or some of that sort, that's 9 times out of 10 going to be your answer. X to that power, or X absolute value of X, or square root of X, or something of that sort. It's going to be that. So don't think too much into it. Now, what's going to happen later on, not right now, and what you would probably see in calculus, is there could be more than just a f of x and a g of x. There could be a f of x, a g of x, and maybe like a t of x or something of that sort. It could be more than one. All right. So I'm going to go to B next, and then we have C, and then we're done. All right. So that is it.